Hey guys, and welcome to Functional Print Friday. So a couple of you are probably looking at the workbench and already taking a guess at what we're going to make this week, and at least one of you is probably dead right, because a viewer of last week's video where we did the sleds for the lathe chucks for taking them on and off suggested that I do an indicator holder for the quick change tool post. And it's a great idea. It's already something I was planning on doing, but it kind of got lost in the priority list. But I do want to go ahead and get that made because just in using the lathe in the last couple of weeks, I've needed one of these several times and I don't want to buy one. I'd like to make one. So let's see what we can do. But before we do that, I want to talk a little bit about next week's video. Okay, so next Friday is the 24th of November. And if I scroll all the way down here on my site, fpfdesigns.com, and look at the first video that I published, it was on 11/26/2021, which means the 24th of November, next week, is going to be the 2-year anniversary of publishing videos on this channel. And guys, I can't thank you enough for all of you that have subscribed. Thank you so much for your comments. Thank you for your likes on the videos. Really appreciate it. Really gets me excited about sharing, every week, whatever it is that I have designed with you guys. So I want to do something a little bit different for next week's video. I'd like to do a Q&A. So whatever questions you have for me, put them down in the comments of this week's video, the video that you're watching right now. Put them in the comments for this video, and whatever you guys ask, I will try and answer them in next week's video. And nothing's off the table. You ask whatever you want. Put it down in the comments of this video. Again, put it in question format in the comments of this video, and I will try and answer it in next week's video. I'm excited to see what you guys come up with. Again, nothing's off the table. Ask me whatever you want, and I will do my best to answer it. All right, back to this week's video. Okay, so we're over here at the lathe, and I want to talk about the problem that I'm trying to solve. So I have just a scrap piece of aluminum chucked up here in the lathe, and what I would like to be able to do is see how true this is running. I mean, let's say I need to make a part out of this aluminum that's fairly close to the current outside diameter of my bare stock here. Maybe it's within 5 thou of my finished dimension. Well, if that's the case, I need to make sure that this stock is running within 5 thou of perfect concentricity. So if I was to turn this on, this guy's not going to spin perfect. It's just not. The stock piece itself might be slightly bent. It might not be sitting in the chuck just perfectly. So I can measure that. And how I would measure that is if I had an indicator that I could hold perfectly still with some sort of indicator holder. And then as this turns around, this indicator is going to show me, because as I push this plunger, it registers how much movement there is at the plunger. So as this guy turns around, it'll tell me, okay, well, this workpiece might be 10 thou out of concentricity. Well, if I make a cut, I'm going to remove 10 thou from one side before I take anything off the other side. Now, I have a way to hold this indicator. I can put like a magnetic base on the waist of the lathe down here and adjust the arm and get it lined up just perfect. That works, but it takes a while. Now, this lathe has a quick change tool post installed on it. So this is the quick change tool post. This is a tool holder, and in the tool holder is a tool. And the idea is, depending on the operation you're doing on the lathe, you need to switch the tool that you're using. You're going to use a different tool for internal boring, threading, external turning, external facing. You can get away with doing a lot with a single tool, but at the end of the day, for most operations, you're probably going to use 3 or 4 tools, particularly if you slide another tool on to chamfer your ends. Like, you get up there pretty quick. And I actually have quite a few of these tool holders, and this is a CXA quick change tool post. These guys aren't cheap. They run, for the made in China ones, they're about 35 bucks a piece for this black metal part. Now, that's cheap in comparison to the genuine Dorian or Aloris ones, which I think are, I don't know, about 100 bucks a piece, but it's still 30 bucks. And I'm talking about that because what I'd like to do is essentially hold the indicator in one of these. Now, there's a couple different ways we could do that. Probably the easiest one would be to buy another one of these tool holders and then just design a piece that fits where the tool is in here. So I would take this out, loosen up these set screws, like a big square rectangular, rectangular portion of our design would go into the tool holder. We'd tighten those down, and then the rest of the design would somehow hold the indicator. And you get the idea. So we'd slide this on. Imagine the indicator is part of it. We'd drop it down in place. The indicator is fixed in position, and we can use the carriage and the cross slide to bring it into position, get it up under our workpiece, and get a measurement. So I would like to come up with a solution that doesn't actually require another tool holder. It'll save 35 bucks and I think will be fun to design. It's also going to be challenging. The way that this tool, this quick change tool post works is, as I turn this handle, this wedge moves down, and as it moves down, this is like on a ramp, so it essentially pushes out. It pushes into this dovetail, and when it does that, it forces these flat faces here against these flat faces on the quick change tool post. Now, I can't think of an easy way to measure how much force it's applying to that when I turn this and give this a yank, but it's at least a couple of 100 pounds. It might even be closer to 1,000 pounds. I don't know. I'll put it up on the screen if I can find a spec as to how much force these wedge style quick change tool posts actually put on the tool holder. But it's a lot of force, and it has to be because our cutting tool is up here. So there's a fair amount of leverage on this. Like, we wouldn't want this guy to move at all. The whole thing needs to be very rigid, so it's got to put a lot of force on it. That also means it's going to be really challenging to design this because we can draw one of these up, but we're not, I mean, there's no way we're going to be able to design this in a fashion that is going to be rigid enough to work exactly like one of these. I think we have to plan for our part that we design flexing when this gets tightened up. I don't see any way around it. I don't think it matters what material we make this out of. In fact, my guess is even this solid steel tool holder in place here, when I drop this guy on and then tighten up the tool holder, my guess is this guy probably flexes as well. It just, it flexes a very predictable amount and probably not that much. But I think when I hit this point and it tensions up and I pull harder, I think what's going on is I think it's actually flexing the tool holder itself. Maybe only by, 1 or 2 thou, or maybe even less than that. But my guess is it is flexing on its own. So here's my thought. We designed something that on one end of it kind of looks like one of these tool holders, but then has a piece that comes out this direction that our indicator can mount into, and it would be held like over here, okay? So I'm gonna need some measurements, so I'm gonna take one of these tool holders and the indicator up to my desk, and I'm gonna get a basic drawing started so we can do some test fitting and figure out where we wanna go from there. All right, here's where I'm at so far with this. I'm gonna stop here, even though I'm far from a finished design, because I wanna make sure that this is actually going to work. I'm really worried about the stresses on this piece and how the material is gonna respond, and also if this is even just gonna fit over those dovetails. So I measured these are 60 degrees, they're not 45 degrees, which is what I would have assumed. And I put some really healthy cutouts here in the corners so that as the force is applied, spreading out, trying to push basically these two 60-degree dovetails apart from each other and pulling these flat faces in, that there's no stress point. There's no corner where this guy's going to crack apart. With this curved piece, the stress should get spread out all the way around there. And I started to think about how to clamp in the indicator. I'm not 100% happy with that because looking at this, so think about it, the workpiece is going to be turning in this direction, and I'm worried that the indicator is going to be able to shift a little bit inside this holder even when this clamp is tightly in place. So I might flip this guy around so that it is clamped in vertically to keep it from tilting off axis. But I'm going to stop because I need to make sure this actually fits. So I think what I'm going to do is actually just print this rectangular portion, and we'll print it down, I don't know, maybe an inch thick, just to see how it fits on the tool post. So I'll do that, I'll bring you back. Okay, so here's our oversimplified test piece. Let's see if it fits on here. And it doesn't, but it is really close. So it actually tells me everything I need to know. It looks like I probably need about another 0.5 millimeter to clear, and I want a little bit of clearance for this guy to tighten up. So I think I'm going to give it probably 0.5 millimeter more room on this side and 0.5 millimeter more room on this side just to keep everything centered up. And I'm going to think through the rest of the design and make sure that the other assumptions I've made are going to work. Just think about all the forces at play. So let me do that. Let me get this to the point where it is more of a finished design, and I'll bring you guys back. All right, here's the updated design for this guy, and I'm excited to see how this comes out. I did end up switching the orientation of the tension or clamp piece to be vertical. So the way that this is going to work is there's going to be an M5 machine screw that goes into this bore here and pushes down against this T-shaped piece, clamping the indicator in. And there's actually a bore in that T-shaped piece as well. So the screw will come in, go into that bore without actually putting any tension on this. So it'll retain this, this T-shaped piece in there once the machine screw is installed. So we'll be able to take the tension off of that, slide the indicator in and out, and then just tighten that machine screw in and clamp it into place, just so we can easily move the indicator or swap it out if we need to. Here, I can hide the indicator and give you a better idea of sort of what that looks like in there. In fact, if we hide this, can see now the recess in there, or the bore in this piece, so that that machine screw comes in and the clamping force will be spread out on the top of the barrel. All right, and back to our full design. I think the only other thing to really mention here is the bore that I added for our threaded rod that is going to allow us to set the height of this guy as it drops into the tool post. And I went through my junk and found a piece of 1/2-inch threaded rod that is fine thread. I did want something that was fine thread just so we don't have a real coarse adjustment on the height adjustment. And it's 1/2 inch, so I considered just modeling the threads in place for it, but because it's fine thread, I don't think they're gonna print so great. Same thing for the M5 threads over here. I've had good luck printing threads before, but they're never as strong as actually just, threading them with a tap. So I think we'll thread these with a tap. We're gonna thread these with a tap as well. This one's probably gonna be pretty tough to thread just given the size. The taps really do tend to grab in plastic, but we'll see how it goes. I'm more confident in that approach than trying to model fine threads in our actual part. And I'm gonna do at least 7 outlines on this print, maybe even 10, so we'll have plenty of solid plastic in all of these bores to get threaded. So, all right, let me print this and I'll bring you back. Okay, so I chickened out and I did not print the whole thing. I stopped at maybe about 45 minutes into the print because I do want to make sure that this fits. I mean, this is not an incredibly long print, nor one that takes a ton of material. I think it's like a 5-hour print using maybe 150 grams or so, but it's long enough that I'd like to make sure that we are now, within the range before we print the whole thing. So let's try it. Might have gone too far. That seems loose. Let's see. Actually, nope, it's already tightening up there. I can still move it, but it's pretty tight. Yeah, now it's real tight. I can still move it if I really try. Let's go all the way till this stops. Okay, now I can't move that, but I can see it is flexing quite a bit, but that's okay. This is only a, our final one is going to be a lot taller than this, so it's going to have a lot more strength, but I can see this one starting to yield probably about there. I can actually see the front face flexing as I tighten that up. That's okay. I think this is going to be strong enough. And even this test one, with it yielding as much as it does, with having these, basically these holes here in the corners, it's spreading that flex out across a wide area of the part. So I think we're good. All right, I'm going to print out a whole one of these and I'll bring you guys back. All right, I let the whole thing print. I actually did make a minor adjustment. I took out about 0.1 millimeter of clearance on both sides just to snug it up just a little bit. Hopefully I don't regret that. It's, yeah, it's loose there. Let's see at what point it starts to tighten up. Starting to tighten up there. Pretty tight there, but I can still move it. And now it's, yeah, it's totally locked into position. See what happens if I keep going. Oh, that gets pretty tight. Definitely tell a significant difference between my short test piece and this. Like, I can pull on this. Let's see if I can get it all the way. Yeah, I can keep pulling this, and I can see this flexing. So this does definitely give us enough leverage to make this guy just continue to flex. Yeah, I got to really reef on it, but yeah. That's okay though, because this is, wow, that is rigid. It's not going anywhere. I can see the front bending back as we squeeze this because it's flexing up here. It's bending this whole area back. Not by a ton, but I can see it with my eye. I can't really see movement back here. I think this is just this length of this face here is amplifying that movement. But that should be okay. I really like the way that that tensions up. Yeah, right about there is where it gets to the point where I can't budget. I can't budget on the quick change tool post. So, all right, let's check the rest of our fits. Okay, so I've got an M5 machine screw. We've got our tension piece that slips into here and should be actually retained in there once we install that machine screw. So let's first make sure that this guy is actually going to fit. Yeah, that drops in no problem. So I think the next thing to do is to go ahead and thread that hole for that M5 machine screw. Now I'm tempted to just do this freehand here on the bench, but and I'm going to be frustrated myself if it's not perfectly straight and gets sideways, because I didn't leave a ton of clearance here for the top of the bolt. Like there's definitely room in there. It goes in no problem. But if we're not straight, it is liable to be running up against the side of that counter bore. So let's actually go set this up in the milling machine so we can get directly above that. It'll help hold the tap for us. And I think we're going to need that for this one anyway, because we've got to get a pretty large piece of material threaded into this hole. Okay, so I've got our workpiece clamped up now in the milling machine. I used a 1-2-3 block and a piece of wood here. I'm not actually clamping against this face out here. The wood's pushing against this face, and then the two rear faces are pushing against the back of the vise. Now, why did I go through all this, right? And what am I trying to accomplish? Well, I had this head down lower, and I lined up this spring-loaded center up here exactly over the bore of the hole that we're trying to tap. And what I can now do is take our tap and our little handy tap handle here. This is an M5 tap. And I can drop this guy into the bore, and I can bring the quill down on the spindle. And this guy's going to compress. The spring in there is going to compress. I can lock the quill. Now when I start to turn this guy and tap this hole, it's going to be dead straight. It has no other choice but to be, because this side's in the bore and this guy's held by the spring-loaded center in the spindle. So if you guys have ever hand tapped a hole, I'm sure you've encountered where, you know, no matter how hard you try and go exactly straight or get started straight in that hole, when you're done and you put your bolt in or you put your screw in, sometimes it's just kind of wonky. This prevents that. If you're ever wondering how to turn all thread or a stud like this into something, all you need is two nuts that fit on it. You just take the two nuts and you lock them against each other, and then you turn from well, in this case, the top nut. So I'm gonna thread another one of these on till it touches this, tighten the two tightly against each other, and then when I turn on this one, it'll be essentially like I'm turning on the head of a bolt, because it'll be locked against that other nut. All right, that guy is starting to snug up pretty tight. I don't want to keep forcing it, because we'll strip out the threads that we have here at the top before before this stud forces new threads into the plastic down below. So that's pretty snug. I'm going to stop there. I can see we are nice and straight. I don't know how well the camera's picking that up here. Probably see it against the grid lines of the mat here. You can see that guy's running dead straight. So let me grab another tool holder and see how tall this is supposed to be. All right, so now we have the right length, and I put a nice big bevel on that, so we have a nice smooth surface up there at the top where we're going to see this. And while I had the right collet in there, I also cleaned up our scrap piece as well. I faced both ends and put a bevel on those so that when I go to use this next time, I can actually get nuts to thread onto it to find the right ones. So first thing we're going to have to do is get our two nuts on here again and lock them together so we can turn this guy. All right, I think that's good. So I guess you're probably wondering now, what are we going to do for that knurled adjusting nut, since it's got to come out over this edge here to hold this guy up? Well, I got just the thing. So what I'm thinking is this guy here will press into this. This is probably going to be strong enough if we just had like a through bore that we threaded. But what I'm thinking is we press a nut into this guy. And then that's actually going to, when we put the lock nut down on top of it, it's actually going to hold that in place. So it's not like this guy is going to be counting on just the tension of the press fit of the nut into our little knurled piece here. Because this is going to be on the threads. This is going to be on the threads pushing down from the top of this once we lock the height. So it's actually going to be sandwiching this piece here between this nut and this nut. Let's go over to the arbor press and get this nut pressed in. All right, that spins on there really nice. So for the locking nut, we could either go with this guy or the brass one. Kind of feeling the brass one. I think that's going to be a neat look on there. Yeah, I think I like the brass one on there. Let's go over to the lathe and see how it works. Yeah, I think that works well. So we can't actually set center on it because we don't have the indicator in here. So let's go back over to the bench and get the other parts fitted for the indicator. All right, we've got our M5 machine screw. This guy should go right in. Oh yeah, these threads feel really nice. Now, as soon as I see the head of that coming through here, I'm going to back it off a little bit. We'll insert our tension piece. And then if we bring this down, it should essentially lock. Yeah, so now our tension piece is captured in there. It's not locked. See, it can go up and down, but it can't come out. Our indicator should slip in freely. Yep, that is definitely completely free. Now as we tighten up on that machine screw, it is going to push this down and not only tighten this, but force it to be perfectly straight up and down. It's clamping it in there. Yeah, that tightens up really nice. I can still force it to turn. Yeah, now it's locked. Okay. All right, let's go back over to the lathe and I guess actually try it. I think we're pretty much done. All right, I've got you back on this side of the lathe so you can hopefully see what is going on here. Yeah, that seems good, but I don't know where center is. So I think what we actually got to do is let's get our scrap piece of aluminum back in here so we can find center and we can actually test this guy. Okay, so what I'm doing here is I'm just moving it up and down to find center. You can't do this if this was an actual tool bit on here, but since it's an indicator, when we're on dead center, it's going to read the highest value. Keeping in mind it's going, so as this plunger is pulling more in, it's moving in a clockwise direction. So when I'm at the point where it is as far clockwise as it can go. That is right on center. So I'll bring down my thumb screw, bring down my lock nut, and I'm just going to hand tighten it. I mean, we just need it tight enough that this isn't going to shift as we take it on and off. Yeah, I mean, there's no way that's going to shift. And now when I tighten this guy up, we are right on center. So if I crank in, may as well put it right at 0. And now we rotate this. We can see how much run out there is in that stock. And it's actually not running out very much at all. It looks like about 2 thou, which isn't a huge surprise. I mean, we're in a collet, but it is a raw piece of stock. So I think we're dead straight on the stock itself. It's just that I think there's a little bit of a bend in the material. You know what? If we come all the way out to the end of this this piece of scrap, we'll probably see more run out, just because I'm sure it's not perfectly straight. Yeah, there's probably about. Let's see. We'll get to our low spot. We'll 0 it. Yeah, it looks like there's probably about 4.5 thou of run out in this material. You know what? I wonder. Guys, as always, thanks for hanging out in the shop with me for this week's build. I really enjoyed the design and build work on this guy, and I'm super happy to see how it actually works here in the lathe. I can't wait till the next time I actually need to indicate something. I'm not going to have to go to my drawer and get my magnetic Noga base, get it on here, get the arm all set up, find the center point, or at least close to the center point, and be able to indicate a piece of stock if I have my forejaw in the lathe, or just to indicate a piece of a workpiece if I flip it around in a collet and I need to see how true it's running. If you enjoyed this video, even if you're not going to make one of these, if you learned anything at all, if you liked watching this, do me a favor, take a second, hit that like button. And guys, don't forget, next week's video is going to be sort of a special video. It's the 2-year anniversary on the channel. Any questions that you put down in the comments in this video, I'm going to answer in next week's video. Really, nothing's off the table. You guys ask whatever you want. If this is your first time on the channel, I do a new functional print video like this every single week, every Friday. A lot of them are out here in the shop, but I do ones in the house and out in the yard as well. So if you're into functional printing at all, there's probably going to be stuff I cover on this channel that you enjoy. So if you like that sort of thing, if you want to see more of these videos, hit that subscribe button. And guys, if you do, I'll see you next Friday.